Kia ora. Let's look at a slightly more complicated example of predicting a precipitate. So here we have a solution of lead nitrate is mixed with another solution of calcium chloride, and we need to work out will a precipitate form or not via calculation. So remember, the cation and anion are from two different sources. The lead is from this solution and the chloride is from this 3 times 10 to the minus 3 moles per liter solution. So the first thing you do is just highlight what belongs to each ion, so we don't mix them up. So put the orange for the lead and the green is for the chloride, and in blue is what applies to both ions. So let's try and work out what is actually happening. So here's 200 milliliters of my lead solution, and here is my 300 milliliters of my chloride solution. And if I now mix them, then we're going to get a 500 milliliter solution. And I hope you can see that our lead solution is now more dilute. Can you see these particles are further apart? I've just ignored the chloride so you can see this clearly. So we can't, in our ionic product, just use this concentration, because you can clearly see that that concentration has changed. It has become more dilute. And so we have to calculate the new concentrations. So how do we do this? Okay, so there's the chloride as well to show that the chloride has also been diluted because the volume changed from 300 to 500. So how do we calculate the new concentration? If you think of C is equal to N over V formula, I always remembered using a caret. So C for caret is N over V. So the round top is the N and the V is at the bottom, because that's a caret is more sharper pointed at the bottom. And now we have to substitute. So we are given a concentration, but it's not the real one. We need to calculate the new concentration. So we have a volume, which is our 500 milliliters, and we need to work out N. So how do we work out N? That's the number of moles. So just like we had 3 particles before, we've still got 3 particles. So the number of moles don't change. So we can work out N using the old concentration and the old volume. So if I do this here, you can see 2.5 times 10 to the minus 4 moles per liter is the concentration of the old one, and the milliliters is 200. Now, normally we change milliliters to liters, but I'll show you why we're not going to bother this time around. So when we work out the new concentration, remember this whole bit over here stands for N. So I'm going to substitute it for N, 2.5 times 10 to the minus 4 moles per liter times 200 milliliters, all divided by 500 milliliters. And as you can see, the milliliters cancel out, leaving me with only the unit for this, moles per liter, which is why I don't bother changing milliliters to liters in this particular case. So let's do the whole calculation. We've highlighted the 2 different bits. Now remember, if you don't know what equation to write, always look at the KSP, because that tells you the sparingly soluble salt. So it's lead chloride. So lead chloride is a solid and its ions on the right-hand side. So now we write the expression. Because of that 2, when we balanced it, we have to raise this to the power of 2. Now I suggest you always link or list what we've got and link them to the ion. So in orange is our lead. Now we remember we've got to change our concentration, which we've done over there. And now it's the chloride. And the chloride, we also have to calculate the new concentration. So again, we take the old concentration, divide by 0.5, and multiply by 0.3, and the milliliters cancel out. So now we substitute into the ionic product. So it's the same as the Ks expression, but because it's not at equilibrium, we use IP, and always put what you're referring to. We're referring to lead chloride. And so we now substitute our new concentrations in there. Don't forget to square. That's a very common error, that you forget to square. Or you might multiply first and then square. Do the 1.8 times 10 to the minus 3. Whoops, there's my... Okay, 1.8 times 10 to the minus 3 squared, and then multiply it by 1.00 times 10 to the minus 4. and you should get an answer like this. Remember, keep a minimum of 3 significant figures during your working. Don't be lazy and just write 1. Say it's 1.00. This is important for excellence. And now we compare this value, our ionic product, with our solubility product, and we can see this is a lot smaller. And if it's not a lot smaller, we have too few ions in solution, which means we're not going to get a precipitate. If any, what will happen is that some of this, if we have a solid, that would go into solution if we had some around. So we will not get a precipitate form. So I hope you can now understand how to do calculations when you mix 2 solutions together where the volume changes.